The James Webb Telescope stands out as the premier global observatory in the field of space science. Its mission is to investigate the enigmas surrounding both our own solar system and distant worlds orbiting remote stars. It also aims to delve into the complex structures of our universe and the role we play in it. In a recent initiative, scientists directed the Webb telescope toward a star located 120 light-years from our solar system. This time, the super telescope has revealed evidence for the existence of carbon-based molecules in the atmosphere of a possible ocean world outside our planet, which has baffled the astronomical community. How is this surprising revelation possible? This finding provides a fascinating glimpse of a planet that differs significantly from any other within our solar system. It raises interesting questions about the possibility of a potentially habitable world in other corners of the vast universe. Join us on this journey to discover more details about this exoplanet. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. NASA's James Webb Space Telescope has made a relevant discovery regarding the exoplanet K2-18b, which has a mass 8.6 times that of Earth. This finding consists of the identification of the presence of carbon compounds, such as methane and carbon dioxide, in the atmosphere of this exoplanet. Webb's discovery adds to previous research suggesting that K2-18b may be a planet with characteristics conducive to life. It appears to have a hydrogen-rich atmosphere and an ocean-covered surface. The first exploration of the atmospheric properties of this exoplanet in the habitable zone was carried out using NASA's Hubble Space Telescope, which transformed our understanding of the system. It is important to note that this exoplanet is located light-years from Earth in the constellation Leo, orbiting a cool dwarf star called K2-18, which is within the habitable zone. Exoplanets such as K2-18b, which are between the size of Earth and Neptune, are a rare category in our solar system due to the lack of similar planets in close proximity. The possibility that K2-18b is an exoplanet with a significant abundance of carbon and a hydrogen-rich atmosphere is intriguing to astronomers. Some experts believe that these worlds could offer ideal conditions for searching for signs of life on exoplanets. The presence of methane and carbon dioxide, along with the absence of ammonia, supports the theory that this exoplanet could harbor an ocean beneath a hydrogen-rich atmosphere. Early discoveries regarding that exoplanet also raised the possibility of detecting a chemical called dimethyl sulfide. This compound is generated only by life on Earth, with most of the dimethyl sulfide present in the atmosphere resulting from phytoplankton activity in marine environments. However, the interference of the presence of dimethyl sulfide in the atmosphere of K2-18b is less robust and requires further confirmation. Further observations from the telescope network should be able to verify whether dimethyl sulfide is present in K2-18b's atmosphere at significant levels. An astronomer at the University of Cambridge explained that although K2-18b is in the habitable zone and has been shown to contain carbon compounds, this does not automatically imply that the planet is capable of harboring life. The fact that it has a radius 2.6 times that of Earth suggests that its core is probably surrounded by an immense high-pressure mantle of ice, similar to that of Neptune. It also possesses a thinner hydrogen-rich atmosphere along with an ocean-covered surface. Although oceans of liquid water are expected on this exoplanet, there is a possibility that the ocean is too rigid or inadequate to support life. However, the researchers have managed to obtain the most detailed spectrum to date of a habitable subneptune. This has allowed them to identify the molecules present in its atmosphere. A member of the Cardiff University team explained that this challenge was met by analyzing the light coming from K2-18b's host star as it passed through the exoplanet's own atmosphere. K2-18b is what is known as a transiting exoplanet, meaning that its brightness decreases as it passes in front of its host star. In fact, this is how NASA's K2 mission was able to detect this exoplanet. This approach implies that a small portion of sunlight passes through the atmosphere of exoplanets before reaching space telescopes, such as the Webb telescope. During these transits, when sunlight passes through an exoplanet's atmosphere, it leaves traces or signals that astronomers can gather to estimate the gases present in that atmosphere. The research team plans to conduct further investigations using the telescope's mid-infrared spectra. This will confirm their findings and provide new information about the climatic conditions on K2-18b. Their ultimate goal is the search for signs of life on habitable exoplanets, an achievement that could revolutionize our understanding of the universe. In addition, the super-powerful telescope has also made other notable discoveries. Astronomers using the James Webb Space Telescope have found complex organic molecules similar to a kind of smoke or smog in a distant galaxy. This finding represents the earliest known example of complex organic molecules in the universe detected by humans. Personally, I find it astonishing and at the same time disturbing that these findings in the far reaches of the universe are transforming the foundations of our cosmology. This discovery is truly shocking. And here's the reason for its importance. First, these chemicals, technically called aromatic hydrocarbons, have been identified in a galaxy that formed when the universe was about 10% of its present age. These carbon-based molecules are found in petroleum and coal deposits on Earth, as well as in atmospheric pollution such as smog. What makes this discovery especially intriguing is that the molecules found are not simple like water or carbon dioxide. Instead, they are large, complex molecules with dozens or even hundreds of atoms in their structure. It is amazing that the universe was able to create such large and complex molecules so quickly after the Big Bang, which defies expectations based on our cosmological models. To put it in perspective, the light that astronomers detected from this early galaxy began its journey less than 1.5 billion years after the Big Bang. The universe is approximately 13.8 billion years old today, meaning we are observing the first steps in the formation of the universe as we know it today. What is most impressive is that this detection is due to the Webb telescope, which will allow us to make observations of this type for almost 1 billion more years. If we could look even further back in time, would it be possible to find more of these molecules, even much closer to the Big Bang? This raises fundamental questions about our science and our cosmological model. Until now, previous efforts to detect complex organic molecules in ancient galaxies could only tell us whether or not the chemicals were present. However, with Webb's ability to provide higher resolution, we can now see the real details of where these molecules are found. Furthermore, the non-uniform presence of these molecules in the early galaxy SP 1847 has yet to be fully explained. Scientists are still investigating why these complex organic molecules appear in certain regions of the galaxy while being absent in others. This irregular distribution raises intriguing questions about the physical and chemical conditions that allowed these molecules to form and persist in some areas while being limited or absent elsewhere. However, what is truly impressive is that this ancient galaxy was already just as massive as our own Milky Way. Despite its young age, it had managed to accumulate an enormous amount of matter, forming billions of stars that contributed to its rapid growth. This challenges previous assumptions about galaxy formation, as it suggests that some galaxies were able to reach maturity much faster than scientists had predicted. Even more astonishing is that its stars have generated as much carbon and oxygen as those found in the Milky Way, despite the fact that SP 1847 is only 1/5 the age of our galaxy. This suggests that the processes responsible for creating heavy elements, such as supernova explosions and stellar fusion, may have occurred at an accelerated rate in the early universe, shaping galaxies much faster than previously believed. As humanity ventures into the unknown, armed with knowledge and a deep-seated understanding, we are humbled by the vastness and complexity of the cosmos. With each scientific breakthrough, we move one step closer to unraveling the mysteries hidden among the stars.